Let's discuss propensity score matching, a powerful statistical technique employed to effectively address and mitigate the issue of self-selection bias in observational studies. So let's consider a scenario where we're examining a particular case. We're specifically looking at how a company's dividend-paying status might be connected to its accruals management practices, which is essentially what we refer to as earnings management. The theory suggests that companies choosing to pay out dividends may possess fewer private control benefits to consume and to conceal, and therefore might be less inclined to fabricate their accounting information. So, the X variable we're looking at is essentially a dummy variable, meaning it's designed to take a value of 1 specifically when the firm is paying a dividend to its shareholders, and it will be 0 in any other situation or scenario. And then our Y variable, on the other hand, serves as a direct measure of the extent of earnings management. Now, the primary issue in this particular case is that the concern is that observable firm characteristics, which are inherently associated with a company's dividend-paying status, actually cause significant differences in the fundamental relationship between that dividend-paying status and the practice of earnings management. To put it another way, it's entirely possible that certain observable characteristics of these companies might account for why they distribute dividends and simultaneously shed light on their earnings management practices. So the relationship here may not stem from the dividend policy or the company's dividend-paying status influencing earnings management, but rather from some deeper unobservable characteristics. So in this scenario, we're facing a classic self-selection problem. This means that companies which frequently choose to pay out dividends might inherently possess other specific characteristics that could in fact account for their earnings management practices. Therefore, to effectively address and mitigate this complex situation, we employ a robust statistical method known as propensity score matching. In this particular scenario, our primary objective is to carefully match each treated firm with a suitable, comparable controlled firm. Therefore, as a crucial initial step, we proceed to execute a logistic regression model incorporating various relevant covariance factors. Ultimately, these covariance factors are instrumental in explaining and predicting whether a given firm is likely to issue a dividend payment or not. Therefore, the resulting outcome will be calculated P propensity score, which is, in that sense, a probability measure ranging numerically between 0 and 1. So, when we're dealing with regression analysis, specifically employing covariance, we first establish a linear index, which we denote as Z. We then take this linear index Z and apply a particular equation. The purpose of this equation is to convert the predicted numerical value of Z into a probability. This resulting probability outcome will always possess a value ranging from 0 to 1. For example, consider a scenario where the Z value is quite large. This would strongly indicate that the firm is consistently paying dividends precisely in accordance with the predicted value derived from the X variable. In such a case, the Z itself will naturally represent a significant number, and if we then proceed to input this substantial number into our calculation, the resulting P-value will inevitably approach the maximum possible value of 1. Now, if the z-score is found to be quite negative and also very small, then in this particular scenario, the probability, or P, will inevitably approach a value of 0. So based on a thorough analysis of the covariance, we can then predict whether the firm has the ability to pay out its dividends or not. One clear example of covariance could be considered as a company's overall performance, such as its return on assets, its rate of sales growth, its corporate size, the total amount of available free cash flow, along with various other influencing factors, which ultimately determine the likelihood of these companies choosing to pay out dividends to their shareholders or not. So once we get the propensity score for firms, we then have two samples, the treated one. This is considered to be the main X variable, a specific dummy variable that takes on the value of 1 for all those firms that are actively paying dividends throughout the entire specified period of time. And the control firms, which are the companies that did not distribute any dividends to their shareholders. And then we are measuring the propensity score between these two distinct groups of samples. And the fundamental concept we're working with here is that we must carefully match each treated company with at least one or perhaps several control companies that possess a very similar propensity score value. What this implies is that when we take into account the distinct characteristics of a particular firm, it becomes crucial for us to additionally select appropriate controls that exhibit a strong probability of consistently paying out dividends. However, the real value, irrespective of any dividend payments, is precisely that they did not issue any dividends. However, by analyzing their specific characteristics, we identify companies that are expected to pay dividends, even if they haven't yet. We then compare these potential payers with the companies that are already distributing dividends. That's the core concept. So ultimately, we refine our sample, dividing it into treated firms and a carefully chosen set of control firms. Rather than simply including all available control firms, we specifically self-select those firms that exhibit characteristics similar to our treated firms, particularly concerning their dividend payment policies. And in this analysis, we are solving for the underlying firm characteristics, both those that are unobservable and those that are observable, which may ultimately drive both the firm's dividend payment status and its earnings management practices. So, once we've carefully matched each individual treated firm with a suitable control firm that has a propensity score that is either precisely equal or very, very close to the score of the treated firm, then through this meticulous process, we are able to achieve a significantly improved and more reliable matching sample for our analysis. Then we can proceed to run the OLS regression, which will allow us to examine the central question of our current study. Now, there are several different methods available, such as one-to-one matching. You also have the option to impose a specific minimum caliper. This means that if a potential control firm exhibits a propensity score that is significantly different or rather falls beyond this established minimum threshold, then we would proceed to exclude the entire treated firm from our analysis. So, in the event that we cannot locate a sufficiently close match for a specific treated firm as defined by the parameters of this particular benchmark, then it is acceptable to exclude some of the treated firms from consideration. So, not only do we identify the most suitable control, but we also make certain that this control possesses a strong propensity score, one that closely aligns with the propensity score value of the firm being treated.
So what if we were to take this particular concept and try to implement it right here?
And for this particular analysis, I'll be utilizing the Finance Research Gate website. So once we've carefully filtered our initial sample, ensuring that each treated firm is matched with either one or a select few control firms, we then arrive at what we consider a normalized and usable sample for our study. And then we can run the regression, and that essentially should be the core idea that truly underpins the propensity score methodology. So we perform propensity score matching to effectively filter the control firms, specifically selecting those control firms that are quite similar to the treated firm, considering the primary X variable, which in this particular case is the firm's propensity to pay dividends. Following that, we proceed to run the regression analysis. So, for our purposes, I'm going to use the Finance Research Gate website, and I'll be selecting a single frequency. Given that both the X and Y variables share the exact same frequency, it makes perfect sense for us to choose the annual frequency for consistency. Therefore, I will proceed to select the starting year as 2000 and the ending year as 2024 to define our specific research period for this study. It is essential that you correctly apply the specified period, and then we will carefully examine the X variables. We are in a privileged position where we can effectively choose and determine the specific return on asset. We are in a position to select an appropriate free cash flow measure.
Or the flow of cash.
Determine. We also carefully select a specific metric to evaluate the potential for future growth. Leverage, naturally. The age of the company. With that, we've pretty much covered the essential aspects of this particular topic. Now, naturally, the primary explanatory variable that we would typically consider here would be the dividend yield, represented as a dummy variable. However, in this specific scenario, we unfortunately don't have access to that crucial data. A dummy, but we have the dividend itself, the amount of dividend. Then we can easily, in a separate section, create a dummy from that variable. Regarding the Y variable, we absolutely need to establish a clear measure for earnings management. This will be our primary Y variable, and I propose we can utilize the absolute value for this purpose.
The growth of value over time.
A higher value of accruals often indicates that the firm is more likely to engage in earnings management practices. And then, as we proceed further into the analysis, it is absolutely essential that we apply a time lag operation to every single one of the X variables. And then right here, by utilizing this particular section, we can create a dummy variable. So, at this particular point in time, we are attempting to create a new variable. So, if the dividend yield actually exists, and of course, it needs to have a positive value, specifically, we're talking about a value that's greater than 0, at that point, we would then incorporate it into our model. And if we're considering a company that pays dividends, then subsequently, we would include the dummy variable. You'll notice here that we have approximately 39% of the firm year observations that actually pay dividends assigned a value of 1. However, the vast majority naturally did not pay any dividends throughout those years. The final step in our process involves addressing and managing those data points that are significantly outside the normal range. Therefore, I will be applying a Windsorization technique to each of these X variables, which have already undergone a lagging transformation. There is no need to one-hot encode the dummy variable, and of course we must not forget the dependent variable y.
At the 1% significance level,
Following that, we will proceed to scroll down to the specific regression analysis section. Within this section, we are presented with the choice of either the fixed effect model or all S. In both of these particular sections, we will find the PSM, which stands for Propensity Score Matching. Therefore, I will proceed to select the specific once-arised Y variable. And then I will proceed to select each of the previously adjusted and lagged variables related to X, specifically including age, book-to-market ratio, cash flow to date, dividend yield, market leverage, and ROA. And of course, the primary variable, the key independent variable, is a binary indicator for whether a company pays dividends. And then the next step is to proceed over to this specific box, and from there we can activate the PSM. So the treatment indicator, which we're referring to as X, is the primary variable of interest. It specifically indicates whether or not the firm actually distributes a dividend. Therefore, to capture this binary outcome, I will be selecting the appropriate dummy variable for our analysis. Now, the covariates are key factors or variables that help us understand if a company decides to pay out dividends or not. So, for instance, we could select as one of these the return on assets, or ROA, which reflects the company's overall performance. Additionally, we might consider leverage, a financial metric that is quite similar in its implications. So our initial step involves utilizing these specific variables to accurately predict whether a given firm will choose to pay out dividends or not. Following this, we will then derive the logistic propensity scores for every single firm in our dataset. Finally, we will proceed to match each treated firm with an appropriate control firm. How many control groups do we need for each treated firm? You'll select that option in this box. Next, we have caliper. If you leave that setting at 0, it essentially means you're restricting the treated group to be matched solely with control firms that possess the exact propensity score or the precise probability number. And that is quite a challenging thing to achieve. So it's really important that you always allow for a certain acceptable margin of difference. For example, in my specific situation, I am permitted to allow a deviation of up to 0.05. So we're going to select the nearest control, but it might not have precisely the same propensity score as the treated firm. We are allowing for a deviation either above or below the treated firm's propensity score by 0.005, but ultimately we are selecting the closest control that we can possibly have available. Any control observations falling outside of this specified range, either above or below, would not be included in our analysis. Furthermore, if a treated firm lacks a suitable control counterpart, that particular treated firm will be entirely disregarded from our sample. Essentially, we will proceed to remove it from consideration. How many controls? Let's say we want to match one control firm for each and every treated firm. With replacement, this particular method implies that you are effectively allowing the single control firm to make multiple appearances within your study. For instance, you might have a control firm that could be matched to a treated firm A, and simultaneously it could be matched to another firm B, provided that their propensity scores are sufficiently close within this predefined range. After all of that is completed, then we can proceed to run our OLS regression. Please allow a little more time to pass. Then observe that the initial sample data includes values like 83,300 and 938. But naturally, that total will be reduced because we are planning to match each treated firm with just one control firm. So to put it another way, we won't be employing every single control firm that's present in our sample. We are going to select control firms that are closely comparable to the treated firm, specifically concerning their decision to pay dividends. This selection process involves matching them based on a set of variables that effectively explain the propensity to pay dividends. All right, so right here, we are presenting the corresponding descriptive numerical data for every single year. The pre-match results indicate that if you were to run the analysis without using the propensity score matching technique, that would indeed be the outcome. As expected, according to the established theory, the dividend-paying firm shows a negative sign, which essentially means that a firm decision to pay dividends correlates with lower earnings management. Why? The reason is that the firm is prepared to openly disclose its cash holdings, and as a result, they have significantly fewer incentives for private control or to conceal any important information. And the t-statistic in this particular case is quite significant. Now, if you were to conduct a propensity score matching analysis, this would then provide a much greater degree of additional robustness if the results from that analysis align with the initial findings. So, in this specific instance, if we proceed to this particular location and then carefully examine, we'll be making a direct comparison between all of the coefficients.
we can observe that the act of paying dividends consistently exhibits negative coefficients even after the application of propensity score matching, which implies that our findings are robust. You'll also observe that the total count of observations once the propensity score matching has been applied ought to be lower, and you can easily locate this detail within the provided information right here, allowing you to examine the figure of 13,000. Previously, that particular number was considerably higher. The primary reason for this approach is that we meticulously filtered the control firms, thereby reducing their overall number to ensure we obtained a perfectly matched sample that aligns precisely with the treated firm.
So that should be it for propensity score matching. Thank you for watching.